Welcome, everyone. Welcome. Thanks for being here for this session that I've been looking forward to the whole morning. If you're standing by the side, take a seat. We're about to start here with our session on the road to sustainable transport. But don't worry, we're not just talking about roads. We're actually also talking about waterways, airways, and cycling as well. So we're covering quite a breadth of transport here today. So my name is Maiko Schaffrath. I'm the founder of Impact Hustlers. We're a community for social impact and environmental impact entrepreneurs. But today is all about representing some of the solutions here that our speakers bring with them and discuss how the future of sustainable transport actually looks like. There's a lot of talk about electric cars, and we'll actually find an example of how we can even push electric cars to be better. We're so excited about that in a second. Without further ado, I'd love to actually ask Lex onto stage. Lex Hoefsloot from Lightyear, the founder of Lightyear. Welcome.
Thank you.
Welcome. You were too fast for the jingle, so there we go. You're the co-founder and CEO of Lightyear. It's a solar-powered electric car, and it's on the test tracks right now, I've learned, and results are promising, so I'm really excited to learn. Can we create electric cars that don't need to be charged? I'd love to learn from you.
Thanks.
Go.
Thanks a lot.
All right.
Great to meet you, and pleasure to be here. So what I'm going to do is just give you a bit of feel of what the journey was we went through and what we're working on. So let me check whether, yeah, there we are. So our mission is clean mobility for everyone. There's a lot of people with that mission. But for me personally, of course, everybody has their own story of how they came to what they're doing. And for me personally, I read in a magazine when I was 12 that climate change was happening. So the Earth was getting warmer, and basically the Earth wouldn't be the same as it was back then. And that as a kid of 12, it blows your mind. It goes like, oh, what we as humans can actually affect this planet as people and make it a planet we don't want to live in anymore. So that became a trigger for me to look for, hey, how can I contribute, no matter how small or big? And for me, I found a way to do that in university. In university, we built a team that built the first 4-seater solar car. So basically, this is Australia. You drive from Darwin to Adelaide, 3,000 kilometers through the desert. And we had such an experience driving that in 6 days, with a car that had never existed before, and we were a team that had never built a car before, and we were building a car that never existed before. And for us, it was a lot of ups and downs. But what we did is, so with this car, we could drive about 70 kilometers an hour without needing any energy from the battery. So you can drive on the sun with 4 people in the car and do that whole competition in Australia. It was astonishing that with the technology we had back then, 10 years ago, that was possible. And it felt like, hey, there's so much more to this than just driving a competition in Australia. And the lesson that stuck with me that in the end, everything is about teamwork. So we were 20 students, we were inexperienced, we just finished our bachelor's, and we were going to build a car that had never existed. And at the beginning of the year, we knew nothing about building cars, and at the end of the year, we learned so quickly, also by being critical to each other, asking yourselves questions, and gaining trust in each other, that in the end, if you are in Australia, you drive the 3,000 kilometers, that you have to trust that the car is going to hold up, right? Because there's big trucks, 3 trailers behind it, they're about 100 times more heavy than the solar car, so everything has to be safe and sound. And we're there competing in the World Solar Challenge, and actually we managed to win the competition as well, which we never envisioned would be possible in the first year we participated. And that made us think that if we're able to drive an electric car using solar in the middle of the outback, basically there's no more remote places on Earth than the outback, or perhaps there are a few, but not many, then we can also make a very big contribution to the big problem that's all ahead of us, because in 2040, there will be about 2 billion cars on this planet. And at the moment, there's about 7 million cars that are electric. So although we might sometimes feel that we're close, right? So every car is going to be electric and the problems are going to be solved, there's still a huge undertaking to get not just the West, but also people in Africa, India, to drive electric cars. So that's the challenge that we felt we have a solution for, and we can start doing something with. So if you then look very concretely to what are the people today that have difficulty driving an electric car, even in the West, right? So on the left side, people that need to drive long distances. They need a bit more range. They might not be living close to charging points, so they need the range to actually go between charges, right? And long-range cars are still expensive, and it's logical because they have a large battery. So if you need a lot of range, you need a large battery, and therefore these cars are expensive. And actually, with the material prices rising, they become more expensive. And then the second group of people, those are the people that cannot charge at home. So they need a public charging point somewhere in their neighborhood, and they're looking for that one to solve their solution, but there isn't any, or it might take too long, or there are not enough of them. So these are the two groups where we say, like, hey, for them, we can be a big solution. So what we're developing are solar cars that we can actually ship to the customers this year already, that prove that even for these two groups, there's a big solution in the near future. So this is the Launcher 1 you see on the picture. So the first car we're bringing to customers just after summer. And so solar cars are not something that we all dream of and that might be there in the future, but actually something we can deliver to customers this year. So what we can do is provide double the range at a 35K price point compared to other competitors, and 5 times less charging compared to other cars in the market. One footnote here is that the Launcher 1 is going to market this year. It's very exclusive, €250,000 car, so it's way too expensive. And in the bottom, you see where we're going to get to in 2024, when we go to the mass markets and actually have cars that can be bought by a lot more people. And for us, it has been quite a journey and a difficult journey to actually build a car that doesn't look ugly like the cars that we build in the World Solar Challenge in the competitions, but one that is safe, can be driven by normal customers, is convenient to use, etc. And combine the technology with something that is actually ready for consumers. And to give you a hint of how that works, this is basically what we do. So on the left side, you see how much energy normal electric cars need from the grid. And what we do is we reduce energy consumption. That's the biggest trick. So going from that, we reduce the aerodynamics friction, we reduce mass and rolling friction, we improve the thermal system, and we improve the powertrain to be more efficient. And behind this is a world of technology. I won't go into that too much with motors in the wheels and how that all works. You can ask me afterwards. But basically, this gets you to about half the energy consumption, so a factor 2. And this is huge, because that means that on that half the battery size, you can drive the same range. So that means that electric cars can become more affordable while still providing a lot of range. And that's the key element everybody should be working on, and I think will be working on in the coming 10 years. Then another advantage, of course, is that with half the energy use, it's half the cost for charging as well, right? And this is even without talking about solar. This is just the car itself. Then if you go into the solar bit, then we add some all-solar electronics, and also the solar panel is quite some larger than normal electric cars have, because they are cars with solar panels. And that gets us to a factor 5. And the factor 5, you have to realize that the factor 5 is 5 times less charging. So five times less plugging in. So if you live in a neighborhood with just a couple of chargers, you only need a charger about once a month, rather than once every couple of days. And the really cool thing is that all of these technologies, as you see right here, we are working on, but the rest of the industry is working on this as well. So every single one of them will improve in the future. So that means that the bar you see on the right, so the little bar of the energy we still need, the black one, is going to be lower and lower in the future. So this is what we're going to deliver this year. But imagine what is possible in the future with technology that's coming to market, where most of the cars will actually be energy positive. a car that produces more energy than it needs. And it sounds like science fiction, but if you count all the numbers, and we're doing that every day, it's actually something that can be done. But it's hard. So this has been hard from the start. So we've done this for 10 years. Basically, my brain cells have been thinking about this concept for 10 years now. And it's getting back to every % in efficiency you can gain and every % in efficiency you can improve on the solar side. So what we did all the way since 2016 is building mock-ups quickly, so you get a feel of how to build a car that's comfortable, that has enough headroom, that all of that. And you see, if back in the days we used beer crates to actually hold these prototypes up. But along the way, we got to our first prototype. This is about 3 years ago. And then the whole facility was filled up with all the parts that we needed to build that first prototype. We actually had a facility. That was a big improvement as well. And from that, this is our biggest achievement in the last year, and that is that we managed to show that on a 60 kilowatt-hour battery, and for those who know battery sizes of electric cars, 60 kilowatt-hour is really not that big. On that battery, we drove 710 kilometers. So that means that on a small battery, you can drive far. Therefore, you can make affordable cars with a lot of range. And on that same day, and this was in Germany, a partly cloudy day, we got 45 kilometers from the sun. And then you might think, like, okay, 45 kilometers, but that's nowhere near what you get from the battery. But the trick here is that you get that every day, right? So you park your car outside of your office, you come back, and the car's charged again. And it means your commute is just recharged. And that's the level you want to get to for basically the majority of Europe, and after that, go to the rest of the world. So what we're doing, of course, as a company, you need to do sales as well. So we had to sell all of these cars, and more and more of them are sold. Build these dashboards, get them homologated, get them certified, and actually get to a point where we can deliver these cars to customers. And by now, we are a team which combines basically two very different fields, where, of course, I come from a solar car racing background. There's a lot more of us that come from that background. But with those people alone, you're not going to build these cars in large quantities. So if you want to do that quick, you need other people as well. And that's why we're very grateful that a lot of people from the industry are joining the company right now. So by this date, we're about 400 people big. And that means you have a lot of critical mass to actually make this happen and get these cars to general consumers as well in 2024. And happy to get people from Formula One and Tesla as well on board to do so. So for us, this is just the beginning. We're going to get the first cars to market this year, and it's personally, I'm mind blown that it can be done this year. But I think there's going to be a lot more people that realize that this is something that is not there in the future, but can solve problems of customers in a very short time. That's what I'm looking for, and I hope a lot more companies, people will join this. There's actually another startup from Germany that is building solar cars, and this can be the end game that we all see for electric cars, right? Where you don't need to charge for a commute every day, and therefore basically have an entity that just always has the energy. So thanks a lot for listening.
Thank you, Lex.
Looking forward to questions.
Thank you. I've got maybe 1 or 2 questions to you to dive a little bit deeper into this, because, again, I'm a tech geek. I've said that on an earlier stage earlier, and I'm just getting excited. I'm about to put my order in, I think. But, there is challenges, right? So, you may have heard of this guy called Elon Musk. I don't know. Yeah. I think he made a quote that said, it's very easy to do prototypes, proofs of concepts, but at-scale production is pretty much the hardest thing about this. And you're at this crucial turning point now where you've proven the concept and you think you will deliver the first cars this year, right?
Yeah, exactly.
How do you think about that problem of, going from proof of concept to really at-scale production?
Yeah, it's a huge difference. We've been living it for the last 2 years. And the main challenge is, of course, that building a prototype, you can be, I do use that word, scrappy, right? So you can get components from left and right and use it to build a car. But actually getting it into production means every supplier needs to be consistently producing the right parts, the right quality, with the right comfort, etc. So they getting that all together, getting the supply chain aligned, basically, that's the hardest part. And then, of course, a car needs to be safe, comfort, so the standards that people have for cars are huge. So the combination of those two made it quite tough to get to this point, but it's one that if you get the hang of it, and you have the suppliers on board, they understand what kind of technology they're working with, that this is the point you can also go to larger. So we're actually going to unveil the production version of the car on June 9th. So very excited for that. The whole company basically is now rallying towards that point where we can actually show what we've been doing.
Exciting. And what's the share? Is there like quite a lot of suppliers already that you can tap into, or do you have to develop a lot from scratch even for at-scale production? Do you have to, fill the gaps?
That's a good question. So Tesla, of course, has been very helpful in creating a huge market for electric cars. That means that a lot of suppliers are by now used to build electric cars and components for electric cars. So that means that on the component side, a lot we can use what the industry is currently producing. There's a few specific components that we had to do ourselves, and most of the electronics on the solar side as well as on the powertrain side. And that's also where we have most of the patents. And that will, but basically, getting that into high volume production is the next step. Yeah.
Got it. And do you think, I mean, obviously, you probably think that this is the future of electric cars, that every car, that Tesla will do this as well at some point? Is that what you think? And if so, what's the barrier for them to do it? Why haven't they done it already?
Yeah, I think so. If you ask the industry of why they're not building solar cars, then they mostly refer to the fact that the amount of energy you get on a day is not enough to actually charge the car enough to drive your distances, right? And in fact, so if you put a 1 square meter solar panel in a Tesla, then the gap is about 10x. So you need 10 times more energy than you get from that 1 square meter solar panel. So there's 2 bits, and of course we showed it. There's reducing energy consumption, that's the factor 2, and then making the solar panel bigger is the factor 5. So that's how you get to the factor 10. But I can imagine if you're Tesla or BMW and you look at the calculations, you go like, yes, we need 10 times more, then you go like, whoa, impossible, right? But it's the kind of blank sheet of paper approach that you need to actually realize that that is possible, and if you tune a percent everywhere, then you can actually get to it. What I do see is that on both angles, so the efficiency one, reducing energy consumption, and putting solar on cars, everybody in the industry is doing that. So, but it's not as aggressive as we're doing it, and I hope they're going to be more aggressive, and they can, of course, also tap into the technology we're developing in their cars. So it is an endpoint for them as well, but they don't see it as close to the future as we do. Yeah.
So you're hoping to pioneer this and then others to copy you, or you're trying to protect?
It's a balance, right? So for investors, you have to protect. In the end, the entity, the company is important to drive this change. So there's a balance between the two. But we have quite a decent head start, which means that we're also selling the solar panels to other manufacturers without that compromising our competitiveness in the market.
Amazing. Thank you, Lex. Thanks so much for joining us today.
Thanks.
Great. Really inspiring, I think. I didn't quite expect that, deliveries could already start as early as this year. So yeah, get your orders in there. But cars is not everything, right? Cars is just one small part of the transport system, and there's much more complexity around transport. And the next 2 sessions, starting with our panel, will actually cover that. And I will call our speakers one by one onto stage and introduce them. I'm really excited to welcome Côme Berbain, Head of Innovation at RATP Group, which is the world's 4th largest public transport company, which I didn't quite realize until I prepared for the panel. So really pleasure to have you and welcome. You're also the head of RATP's autonomous vehicle program. So I'd love to learn more about that. And you served as the CTO of the French state. So welcome. Have a seat just over there. Welcome. Next, we have Virginie Seurat, Vice President at SEABUBBLES. Now, we've heard about solar-powered cars, but actually SEABUBBLES is a flying boat. So excited to learn more about that. You know, you can't just replace conventional boats, but it also can be an alternative for urban and suburban transport. So excited to have you. Have a seat. And last but not least, we have Olivier Issaly, CEO and co-founder of Zenride. Zenride is a company that's partnering with large corporates to offer their employees subsidized electric bikes as a sustainable alternative to their commute, often replacing cars, for example. So it's really excited to have you on here as well. Welcome, have a seat. There we go. We'll talk about that in a second. It looks exciting. Great. I want to start with you, Côme, actually, as we kind of broaden our focus a bit, you know, from individual transport also to transport systems. How are they interacting, and public transport specifically? I think to me specifically, as an outsider, I feel like public transport hasn't really changed that much. Like if you look at trains, you know, they haven't been invented a few years ago. They've been around for a while. You look at trams, they have been around for a while. And I'm sure your perspective is quite different on the innovation happening. But fundamentally, it's still relatively similar solutions that we've been using for a long time. So the question to you is, you know, what is the state of public transport right now? And where do you see it going in the future?
So thanks. For the question. Public transport is a long-term service. We just saw cars changing every 5 years, 10 years. A train, a metro lives 50 years. We are the masters of durability, of longevity of buses and trams and trains. And that's a huge advantage when you want to reduce your carbon footprint. If you change your car every 5 years, then even if you get an electric car, the total amount of CO2 is still higher than keeping a very old car. And you need to look at the complete computation of CO2. Today, we are doing basically three things in public transportation. The first one is decarbonizing the existing system. We are very lucky. Trams and trains and metros are electric. So that's have a very good CO2 impact. And the other thing that makes CO2 impact very good is that we are pulling people. So the efficiency to transport one passenger on 1 kilometer with a metro or with train it's almost impossible to beat. The only thing that beats that is bike.
There we go. We'll come to that.
But if you compare to a car, it's very, very, very different. Today, what we have, which makes a lot of CO2, is buses. And so we have a huge programs to replace all the buses here in Paris, but also the buses we operate in London and in other cities by bio-CNG buses or electric buses. And we start also looking at H2, hydrogen buses.
So it's both about the transition of the existing system as well as new technical innovation that you need to integrate into this puzzle of the public transport system, right?
Yeah. So that's the first idea is make the existing system clean. The second idea we have is we need to create new way of moving. And first we need to make people public transport for people easy to use and convenient to use. And for that there is one big revolution that starts to become classical today, which is mass. We spoke a lot about mass on the last years, but today it's something you use and you start forgetting that it's so innovative. And today we have mass applications, and you can use it today. You can change. You can use your bike and then get on the metro, and that's something that almost is not innovation anymore. But you need to go further on that. And the question of integrating with other means of transport, like bikes, like other things like boats, is something that should be done and is done, but need to be continued. And the other thing we do with that is we create new way of transport, autonomous vehicle is clearly something that we are looking at. We're looking also to urban air mobility, flying taxis. Those are very promising, but those are clearly very innovative. We're not yet at the point, we have lots of experiments. We are now at the point where we start creating real-time service here in Paris, but also anywhere in the world.
Amazing. Let's look at one of them, companies pushing the boundaries on innovation, and also a solution that we see here in front of us that I could very well imagine being integrated into public transport systems as well, into all kinds of use cases. We'll talk about those. But yeah, tell us more about what this is. What is this flying boat? How does it work? And what's the state of your development right now?
So SEABUBBLES is the first flying boat powered by hydrogen. So it's a zero emission, zero noise, zero wave navigation, basically. We have to keep in mind that in terms of carbon emission, a third of carbon emission are due to mobility. So if we address mobility, we address a big part of it. And we all have to play our role. So politics has to encourage the development of new infrastructure and sustainable infrastructures. Industrials have to push boundaries in terms of innovation. And as consumers, we have to make the right choice. Take the walk if you can, take a bike if you can, take the public transport, and make any choice. So in terms of technologies, as industrials, we are using the cutting edge of technologies to support the ecological transition in the mobility field. So basically, we have a holistic approach, not only about the propulsion system. Having a clean propulsion system, of course, is a mandatory, and this is an electric boat. But when you look at electric vehicle, either you can go on battery, which is usually the one that you know, either, and that's the choice we've made, we are using a hydrogen fuel cell. And why we made this choice is because hydrogen is the second, has the very high density of energy, the second biggest after nuclear, basically. So hydrogen fuel cell has a density 7 to 9 times bigger than a battery. So we can get on board more energy in the same volume. So we have a better efficiency of the energy, and it reflects on autonomy, of course, and the refueling is only 3 minutes. Then the infrastructure, you can see that we've got wings under the boat, because we are looking on the structure of the boat, how we can make it more efficient. And so that's why it's looking like a car, basically. It's more aerodynamic. And the foils are helping us. Usually people are using foils to go faster. You can see that in racing. But we use the foils for reducing our friction with water. And so by this choice, we are reducing our need in energy by 35%. We've got the artificial intelligence as well is helping us to...
We'll dive deeper into that.
So there is a lot, the technology can really address the ecological transition.
And where are you on the journey? Now we see a model in front of us. How real is this already? Can you just give 2 sentences on the stage of development right now?
There is a lot of very interesting projects going on in the mobility fields. We are currently in production. We are a French startup based on the Annecy shores. So it's very nice. And we are working on pilot lines for major city in France. And abroad as well. We are very well advanced in the Middle East, where boats will run.
Got it. Now we heard about a need for change in public transport systems. We heard about cutting-edge technologies. And now I'd love to move to our next guest, Olivier. You haven't invented electric bikes, but you're bringing a real important innovation of making sure that more people use them and that they substitute less sustainable energy. So give us a brief introduction of what role you think bikes play in this whole puzzle of the future of transport.
Yes. indeed, the bike is a very obvious and pragmatic.
Can't hear you.
Let's change. Yes, the bike is a very, as you said, obvious and pragmatic solution, quite low-tech solution. Almost everyone knows how to bike, but the main issue is to put a bike in the hand of as many people as possible. We know that about 60% of the car commute are less than 10 kilometers, so there is a huge possibility of conversion to this very simple solution. And that's what we aim to do at Zenride. So in few words, Zenride, we provide a bike leasing solution for companies who aim to reduce the carbon footprints of their employees' daily commuting. And we do so with bike leasing, with the equipment and all the services, insurance, assistance, maintenance, and so on, of which the rent is shared among the employer and the employee. Mostly the employer, about 70% for the employer, 30% for the employee. And the idea is to reduce the gap of accessibility to get an e-bike, because yes, it's an obvious solution. It's very easy to bike, but what we observe is that an e-bike costs about 2,200 or 300 euros approximately on average, and the median revenue in France is less than 2,000 euros. So this gap is very important, and if we want the bike share to grow up to 10, 15, 20% on the long term, someone has to do an effort, and we believe that companies can play a major role in this effort to promote the bike, and that's what we do with leading companies like Saint-Gobain, like Veolia, like Accor in the hospitality industry, and other companies. We allow them we help them to equip their employees with this obvious solution on the day-to-day.
Yeah, we'll dive a bit deeper into the role of companies and how you see it in a second. But I think there's one elephant in the room potentially as well. We're sitting in the middle of Paris. We're talking a lot about urban solutions, or at least that's what's being associated sometimes with, some of the best public transport options are in urban areas. In Paris, I live in London. It's great public transport. Like, it's not much to be improved, I think, in many ways. But we're talking about a lot of urban applications, but the elephant in the room is like most people don't actually live in urban areas, or a lot of people are actually outside of urban areas. So how do we make sure that these systems work for all of us? Who wants to start on that question and making sure that we can connect everybody to the right sustainable transport option?
So perhaps I can comment on that. In fact, it's not just a question of urban areas. It's a question of density of the areas. Paris is a small city in size. The city of Paris is quite small, and it has a very dense public transport network. You can live without a car here, no problem at all, and it's what people are doing. But if you start going a little bit further, you're still in the Paris area. You're still in Ile-de-France. But if you live in the second or the third suburbs layer, then you still have some buses and some trains, but less and less. And at some point, you don't have the choice. You need to take your car. That's why we need to create new services for those people. The classic existing services with buses and trams and metros, those areas are not dense enough for those services to be the good services. Mm-hmm. So that's one of the things we do at RATP. We are starting now to create services for low density area. And for example, now we are working on autonomous mobility service in the furthest part of the suburb here in Paris, at Saint-Rémy-les-Chevreuses. And we have an autonomous vehicle that allows people to go to the station and don't take their car to do 2 kilometers to go to the station and have the car park of the train station filled at 8 in the morning. And we need to create those services, and we need to create those services with the people locally, because the solution for those areas are not the solutions that we have in the dense city centers today. And that's the new frontier for public transport. We can add more metros. It won't change that much what we have in dense areas. It's low density areas that are the very important parts that need to be addressed.
Virginie, what's your view on this, and how does SEABUBBLES fit into that picture?
I think if you want to switch to a more sustainable mobility, you have to bring benefits to people. So either it's cheaper, either it's easier, either it's faster, but we need to address this. So why you're taking the tube? Because basically it's faster, you've got the traffic jam, etc. When the density of the network and the grid is very important too. So I would say it's a mix between the political actions that really need at the beginning, when you've got a new innovation on hydrogen, you need to develop the infrastructures. So you need to focus the investments on this, because of course at the beginning, the innovation, when you've got industrials working on it, the capex is higher. So you need to encourage this. So I would say first the political engagement on it, and we are very lucky that now in Europe we've got a major focus on. It has been the focus now. Everybody is looking at this, and we can see that over the last 2 years, where it was only talking, now we've got the financing aligned with the political decisions. So that's number one. But it's not fast enough. Basically, it's not going fast enough. And the second thing, I really believe in the consumer experience, the passenger experience. Why people are going to switch to something better? Because this is amazing. When you're, I'm talking for, I don't say electric bicycle. When you're help to move, people are going to switch. When you're on a flying boat, people maybe they wouldn't choose the fact that they have 35% less of energy needed. Maybe they just want to have no more seasickness, because they don't feel the wave, because you fly 60 centimeters above the waters. So if we are bringing benefits and we've got the encouragement of the development of the infrastructures, then we won't have to force people to switch to this kind of sustainable mobility.
Exciting. Great. You want to go on that question, on the same question?
Yeah, we believe we want to include everyone in this effort. Right from the start, it was very important for us to have quite an inclusive offer. We mean inclusive on several aspects. The first one is that at our clients like Saint-Gobain, like Veolia or others.
SEABUBBLES soon.
Yeah. The offer is for everyone, for the top management, for the first employees. Everyone can access the offer, the bike leasing offer by Zenride. And it's very important because in some other mobility, in car, for instance, sometimes it's only reserved for the top management. Right from the beginning, our clients wanted to offer it to everyone, and that's the first inclusive aspect. The second one, which is we learned along the way over the last 3 years, is to offer the service in all geography, in all the territory. Companies like Saint-Gobain, Veolia, Accor, or others, they have a physical presence everywhere in France, not only on services but also on the industry, strong industries in smaller cities. And they offer the service also for all these subsidiaries, and we are able to accompany them everywhere in France. And for us, this second inclusive aspect was very important, because we learned that the demand there is even more important than in main cities like Paris or Lyon or Bordeaux. And why? Because quite often on this industrial side, the revenue are lower than it can be in Paris or elsewhere. So the gap of accessibility, because of the price of e-bikes that I mentioned before, is even stronger. So you need an incentive of your employer to get an e-bike. And the second reason is quite often the mobility offer in this area is very sometimes non-existent, or it's very often it's the car or nothing else. And so, but employees there, they want to do their efforts also there, as well as people from the main cities. They also want to participate to the effort of going to a more greener mobility, and so they are demanding a solution, and especially from the employers. So that's why we work on this aspect of inclusive mobility.
Got it. Let's talk a bit about the investment needed to make all this happen. We already touched on it a little bit. Actually, there's a bit of a connection between RATP and you, because RATP has actually invested in you, and you closed the funding round. So there's already some links between all these different actors.
Not in SEABUBBLES yet.
There we go. Got to have a conversation afterwards. So there's already some links between the different actors in the transport system, public transport companies taking stakes in private players, bringing innovation, etc. But then also is the role of the government, there's the role of VC firms, private equity, etc. A lot of different actors that need to invest in this space. Côme, what's your view on this? Like, where are we at the moment with investment into sustainable transport? And do you see like a gap of actors having to step up, whether that's governments or the private sector, to make this sustainable future reality?
So I mentioned the fact that we are replacing all of our buses. Just to give you a number, it's more than 5,000 buses. It's a huge investment, and you need to change the buses, but you need also to change you need to get the power to them. You need to change the bus centers. You need to change almost everything. It's a huge investment for the region. And this kind of investment, we'll see, it's mainly public money. It means the cities are today investing hugely in this transition. Private sector also has a role to play, of course, especially in development, in innovation, and in creating new things. And there is a lot of money of that today, even sponsored by the states. We have a huge we have huge funding from France, but from Europe. We have this Green Deal with lots of money on innovation, and we need to have the mix of public and private investment to be able to do something. But clearly today, we can go more, of course, but there is already a huge effort. For me, the limits today is not the money. The limit today, it's the ideas, and it's the engineering power. It's how do you make those ideas real concrete. And today, the limits is there.
Virginie, how about you? Is it the money, that more investment that maybe you need or other solutions need, or what are the biggest hurdles from your perspective?
Of course, when you go on industrialization, you need money. But money is not the issue. We are lucky to be in the hot topic of like everybody now is focusing on sustainability. So there is a lot of money. But I would say organizations. Basically, we've got a lot of money, a lot of initiatives, and we need people making it happen. So it's about having conversions of projects. Just to be very concrete, it's not about having a flying boat or sailing or making a pilot line in a city. It's about having a consortium of the politics saying, okay, I want to introduce this kind of solution in my city, then to find the right hydrogen supplier able to have the instructor built. The certification and regulation are key as well. So if we want to make things happen, either we talk big, either we start to make small. So I'm very encouraging to start at the first step, and step by step, we are building a more sustainable infrastructure.
Amazing, thank you. Olivier, how about you? What's the biggest hurdles for you? You just closed an investment round, so you're probably fine on that front. But what do you think on a systemic point of view is like a need for more collaboration between different actors, more investment? What do you think about this?
Yes, as you mentioned, we just welcome RATP as an investor, and we are really happy to have this complementary solution. We really believe bike is complementary to public transport. We see it every day in the orders of bike, the many foldables bike, people taking them on train or else. It's a significant part of our bike fleet. So yeah, we believe in the complementary in public transport. For us, the investment is very important because even if the bike is an obvious pragmatic solution, there is a huge effort to be done to promote it, to put it in mind of people for all the small commute, the less than 10 kilometers commute that can be very easily done with an e-bike. Yeah, the effort to promote it, and we do it especially towards companies, large companies. The effort is important. And that's what the investment is for. And on a more large scale, I would say what we are part of the actors that put their energy to develop the usage of the bike, develop the bike. But the main what we expect more from government, especially, is to invest on infrastructure in bike lanes, secured bike lanes, secured parking for bike, especially in main cities, because the safe issues are quite important. This investment in infrastructure is really important, and we need both. We need infrastructure to convince of the usage. The usage enables convince to invest in infrastructure and so on. So both are needed. We work on the usage, and we help governments will invest in infrastructure.
Got it. Amazing. Thank you very much to the three of you, and thank you very much for joining today.
Thank you.
All right. All right, there has been this big elephant in the room that we haven't actually covered yet so far, and that's aviation, right? Maybe some of you have taken a flight here because you're not quite situated next door. Anybody taken a flight here? No shame, unless you're flying from, I don't know, London, for example. I think it's a bit... OK, so let's learn a bit about aviation and innovation happening in the aviation space, and how learn how we can actually transition the aviation sector into a sustainable future. So I'm really excited to welcome on stage Katya Akulinicheva, CFO of ZeroAvia, which is a company manufacturing hydrogen electric aircraft and promising a bright and sustainable future for aviation. So really excited to have you. Welcome. Welcome to Paris. I think you traveled here
by rail. Yes.
By rail. Okay, good. Green stamp of approval. So welcome very much. Tell us about ZeroAvia. What's the technology you've developed? What is hydroelectric airplanes, and where are you at in your stage of development?
Absolutely. So first of all, small correction. We're not actually making new planes. We're an engine manufacturer, and that's a pretty important distinction for us because we think that's actually the fastest way to get the technology to market. So we're building hydrogen electric propulsion systems that can be retrofit into existing airframes that are already out there in operation, but also to new airframes that will be produced and purchased in the future. So we were set up about 4 years ago with a mission to decarbonize aviation. At the time, we had not yet committed to hydrogen. We looked at all the different ways to get there, and we thought that hydrogen, and specifically hydrogen electric, was most promising. Hydrogen, I think, as was mentioned in the panel, we think is energy dense, potentially green, and as a great solution overall. But using it in a hydrogen electric combination allows us to have the most efficient and low cost system, as well as having the green kind of energy carrier in the form of hydrogen.
Yeah, let's look at the technologies that are available generally beyond, and why you've chosen hydrogen electric. So what's available there? What is hydrogen electric really? How does it work?
Yeah, so I guess the range of solutions being explored today are battery electric. So I think we're all pretty familiar with that, but using the same in aircraft. Hybrid, where typically it's a battery solution that is used typically in cruise to supplement power, but most of the power still comes from jet. There's, of course, a big movement around sustainable aviation fuels, and specifically recently a lot of attention to synthetic fuels, where you make hydrogen, fuel using CO2 and hydrogen as inputs. And then finally, hydrogen, we think, is kind of another big vector, but there are companies working on electric solutions like us, but also on combustion, where you're burning hydrogen directly as a fuel. And so to explain a bit more about what we do, so we store the hydrogen either in compressed gas or liquid form on board the aircraft. So really, for us, hydrogen is like a battery. It's a store of energy. And then we convert it back to electricity on board the aircraft using a fuel cell. That's sort of basically a reverse electrolysis process. So rather than making hydrogen from electricity, we convert it back to electricity on board. And then the propulsion system is electric, like it is in a battery electric system. So we're really just swapping the battery for hydrogen.
And how far does your technology have to go hand in hand with the design of the aircraft? Is it something that can be used in current designs almost, or what's the challenge there?
Yeah, so we've started working with small airframes. So our first prototype was using a 6-seat airframe as a target, and our first commercial product that we're working on now targets 10 to 20-seat airframes. There, we can work with the airframes exactly as they are, so we don't need to make any changes structurally. We are mounting the tanks in a different location to where the current fuel tank is, but that doesn't require us to recertify the airframe. So from a regulator perspective, it still is the same airframe, it just has a different propulsion system. And that's very important because it means we can get to market much faster. We don't have to recertify the entire airframe, which is quite a lengthy and expensive process. Once we get into larger airframes, which we absolutely intend to do, because that's where the commercial opportunity ultimately is, but also the impact, and that's what we want to do. There, we will need to make more and more changes to the airframe design, but our strategy is to do that together with the airframe manufacturer, rather than for us to kind of integrate further into that part of the chain. And that is pretty consistent with how the industry is structured today. Today, you have engine manufacturers, you have airframe manufacturers. So we are not trying to change that. We're just trying to offer an alternative engine that is green.
And work hand in hand. I think with the example with Lightyear, obviously completely different industry with cars, but really the thinking of trying to rethink every element of the car, that's something you do in collaboration with the industry.
Yeah, and I think, automotive is already not easy. Aviation is that much harder. To put anything new, even if you want to change the seats on a plane, it's a process, right? So once you start making more structural changes that affect aerodynamics of an airframe, it's heavily regulated for very good reason, but it does mean that, to the extent that you can minimize those changes, your road ahead is a bit easier. So.
Yeah. Let's learn a bit more about your stage of development now. So if I'm a big aircraft manufacturer and want to work with you, can I already buy this right now? Or how far are we away from this actually scaling and being used at scale? Yeah,
unfortunately, we're not in commercial production yet, but we're working on our first commercial product right now. So we should have this flight demonstration of that in the next month or so. And then the road from there is really to finalize the kind of what's called certifiable design, so locking everything in, including all the components that go into it, going through the certification process, and then bringing that to market. So we're targeting commercial introduction in 2024 of our first product, which is for 10 to 20 seat airframes. So not today, but it's not too far away, assuming that everything moves smoothly, which is not entirely in our control, because this will be the first time that hydrogen electric propulsion is certified for commercial use. But then in parallel, we are already working on our next product family, which will power larger airframes of 50+ seats, which is really kind of the bread and butter of the regional mobility market. And there we're targeting introduction in 2026 of the first product. And then over time, we will be effectively just increasing the power and the range of those solutions to serve larger and larger airframes.
Amazing. So what I already heard there is there's a real big importance on collaboration in the industry. How do you feel the other, especially the big players, how do they think about this? Are they kind of fully aligned with you and ready, or is there still a journey for them that they're on as well?
I think it's actually been really interesting to watch how it's changed in the 4 years that we've been at it. So I think at the beginning, hydrogen was not really on the map in terms of a viable way forward for commercial aviation. And generally, there were a lot fewer commitments from anyone, from airlines, airports, but also the OEMs. And so it was kind of something around the fringes. So when we started pitching our solution, it was a pretty tough sell. In the last few years, a number of big majors have made announcements around broadly mobility, clean mobility, but also specifically hydrogen. So Airbus announced their ZeroAvia program, which is all about hydrogen. Since then, a number of other large manufacturers have stated their commitment and also are trying to figure out ways to collaborate. So we have discussions ongoing with pretty much all the majors the airframe level, also the engine level, and also the kind of suppliers into the engine. So really across the chain, to find ways that we can, I guess, do what each of us does best. So where we can, move quickly and sort of iterate faster than they ever can, but then we can also leverage their experience and their resource capabilities to get things like certification, industrialization set up faster than we could ourselves.
Yeah.
So.
What's the biggest hurdle at the moment? Is it really the technology, the development of the technology, making sure you have a good proof of concept? You say you're going to have a flight demo relatively soon. Or is it regulation? Is it other factors of industry collaboration? What is it?
I'd say for the first product, it's primarily certification. We have the technology that we need for that first prototype. It's not fully packaged and sort of on the airframe yet, so there's a bit of like a system optimization and engineering left to do, but that's more question of time rather than binary, is it going to work, is it not going to work? But regulation, we haven't gone through the process yet, so we don't know exactly how long it's going to take. The blueprint sort of for which testing we're going to have to do and when, et cetera, has not been set. So that's where we see greatest uncertainty for the first product. As we look at the long-term roadmap for larger airframes, there definitely are technological improvements that need to be done, but they're not in the order of 10x or above that. They're more in the order of sort of 2, 3, 4x as we scale to larger and larger, and we do have a credible pathway for how to make those happen. So.
Amazing. Looking forward to that. What do you think is the role of, I mean, you touched on it already a little bit, but of startups developing new technology, pushing the boundaries, and then established players? Is it really kind of a case of disruption, or is it more a case of collaboration?
I think it's collaboration. It doesn't start with collaboration. I think it's disruption first, but I think we need collaboration, and so I think we want to get there, but I think it's kind of showing the larger companies that it's possible, and also showing, I guess, ecosystem interest in doing it has been really important in getting that collaboration to move. So in our case, for example, we've always been really focused on partnerships across the chain, and it was starting to make some of our first few announcements, both with airframers, but more importantly with the airlines, who are ultimately the customers, that has really gotten things to start moving faster. Because I think once airframe manufacturers realize that airlines want this, they want to pay for this, they're prepared to take risk now to kind of innovate and figure out how the landscape is going to evolve, they start to reposition their resource allocation internally and have a greater interest to do something together. I mean, it's quite a rosy picture. It doesn't always work like that, so not everybody wants to collaborate, but I would say that in the last few years, it's moved more in that direction. And I think that we can arrive at some interesting models. And actually, also worth mentioning that aviation generally has a lot of joint ventures. So companies are used to working together because it's so expensive and so long kind of time frames to bring something new to market. So it wouldn't be a new thing for the sustainable aviation movement, but it's about kind of the right partnerships where each party, gains something and has the right risk allocation.
Yeah. How about the challenge of price, right? I mean, all big manufacturers are optimizing for price, for lower fuel consumption, things like that. They're on this, like, probably slowly hitting the limits of what you can do with the conventional technology burning oil. But what's the, like, roughly the ratio of the price of a solution like this once it's commercialized versus what we have out there right now?
So our target is actually to save money for the operators. We have two levers that we can affect. One of them is maintenance costs. So engines have expensive maintenance because they're quite complex machines. There's combustion going on, a lot of friction. So you have to overhaul the engines quite frequently, every 2-3 years, and it costs a lot of money to do that. Because our system is electric, similar to an electric vehicle, maintenance is less frequent and it's less expensive when it does happen. So that's the case for the electric propulsion system. For the fuel cell system, it also has longer time frames than, for example, battery does. So the one big lever is maintenance costs, and that's something that we can use pretty much straight away. That's not something that's a question of economies of scale or something like that. Then there's the fuel price. So of course, today, if you wanted to get green hydrogen at an airport, first of all, you wouldn't be able to get it, but even if you could, it would be quite expensive. So there's the availability and the price question. But there's a break-even point where hydrogen can be actually much cheaper than jet fuel for operators. And that's a question of scale, sort of, at the airport. So in our estimate, if you have more than 6 flights a day on hydrogen at an airport, it makes sense to have on-site electrolysis, which can significantly reduce the cost because you don't need to transport it. And there you can actually start to save money by using green hydrogen rather than jet fuel. But that will not be available immediately to every operator that adopts the solution, because it is a question of scale and local dynamics, such as electricity prices and things like that. But when we sell our product, we tell operators we will at most charge you what you're paying today, but over time we hope to generate savings.
Oh, wow.
So.
What is the biggest selling point for your technology? Is it companies saying, okay, we need to save cost, and that's what excites us about this, using this in the future? Is it a regulatory pressure? Is it we've committed to be this net zero company, but now we've got to do something, or a mix of all? What's the biggest driver that gets companies to actually use this?
I mean, I would just say it's future-proofing their operations, because they know whether it's regulatory or economic, that's where things are going. And the earlier they understand what that means for them, and the sooner they start making decisions that are aligned with that future, the better for them. Because you already have, otherwise they'll end up with, if they buy a new fleet today that cannot be future-proofed, they will probably get stuck with stranded assets in the near future. Airframes typically are in operation for 20, 30 years. So they do care about that sort of time frame in terms of being able to extract economic value from them. It's not something like cars that we change, much more frequently. So it is really important for them to understand how buying decisions today can be impacted by sustainability and what role we can help to play within that.
Are we in a bit of a gap at the moment where we don't quite have the technology of the future scalable yet, but at the same time, as you said, the airframes last 20, 30 years, that's already quite close to our deadlines for carbon reduction targets, etc. What do companies tend to do in these gaps right now? Do you see that there's a gap at the moment where companies are like, we need to buy planes. What do we buy now?
So I wouldn't. So if you wanted to buy a plane, if you decided today to buy a plane, you would not get it for another 2-3 years anyway. That's how purchasing in the industry works. The time frames are very long. So it's actually critical for us to have these conversations now for purchasing decisions in 2-3 years time frame when we actually will have technology to offer. Now, in 2-3 years' time, we will not have an A320 flying on hydrogen electric yet. So we fully acknowledge that we don't have the solution for all sizes in that time frame. So we do see ourselves as one of a portfolio of solutions in that medium term. We want companies to work on other options that are more viable. But we think that without alternative propulsion, we will never get to net zero in any kind of time frame. So we do have to create space for that technology now for it to be able to scale to the larger planes over time. So I think it's kind of portfolio in the near term, but with a credible place for new propulsion so that it can increasingly take larger share over time.
Bit by bit, okay. Very, very interesting. Do you see that there is a general move away from aviation for certain use cases? If we look at regulation, there's governments discussing regulation around banning short-haul flights. Actually, it's happened in some areas already. Do you think there's a general move away where there's other alternatives that can be, whether that's like a flying boat or anything else?
Yeah, for sure, over the last couple of years, our sort of patterns of movement have changed. But there are definitely big levers that have led to a decline. But there also are new patterns of travel. People are now living in some ways more mobile lifestyles where they work remotely from places, they spend longer abroad and things like that. So I think there are also some new sources of demand that we didn't have before, as well as reduction in the kind of single meeting business trips and things like that. So I think there's changes in demand, and then there's also changes of how that demand is met, regulatory, but also preferences, flight shaming, all of that. I don't see a world where we would not be flying at all. Definitely there's that kind of short-haul distance where car or rail can offer a much better alternative, and we're very much open to that, which is why we want to scale our tech to the segment above that, the one that where rail can work in certain regions, but in a lot of regions it just wouldn't for various infrastructure reasons. So patterns are changing, but we think that there's definitely that segment is going to be attractive from a kind of commercial standpoint for a long time.
What do you think individuals, but also corporates that are now thinking about their role and their responsibility? There's plenty of corporates flying their stuff around the world, and much of which is necessary, but some of which may also be able to be cut as well. What is it at the moment that individuals and companies can do to help companies like ZeroAvia, eventually get there to bring solutions? Is it like trying to cut down on aviation in the short term and then doubling down once the sustainable alternatives are there, or what's your view on our responsibility, whether it's companies or individuals?
Yeah, I mean, I think at an individual level, I do think we have a responsibility to reduce our footprint. All of us have different footprints. For those of us who fly, that's definitely a big one. You can look at various ways to offset that and reduce unnecessary travel. I still think we have a responsibility to do that. But again, I don't think that means reducing it to zero. I think it just means reducing unnecessary travel. At a corporate level, I think the biggest thing we can do is continue to take risks and collaborate. I think that more of that is still needed, and I think that will help some of these new technologies come to market faster. Because it does work as a snowball effect. Like once there are more companies working on it, more partnerships, greater appetite from everyone to move together, things start to happen a lot faster. That's definitely been our biggest learning in the last few years, and the more of that happens, the sooner we'll be able to offer a different set of solutions, and people won't need to make that trade-off.
From Lex, we heard the importance of really establishing the supply chain for innovative solutions. Is that where you spend a lot of your time as well? You know, you're obviously an element of the supply chain.
Absolutely, and I mean, in particular, because a lot of the components we use have been developed for automotive, so they have not been developed to an aviation certifiable sort of standard. So actually developing an aviation compatible supply chain for hydrogen electric is something that we're having to do. So that takes a lot of effort. And also there's kind of some things you might not even think of, but for example, we're going to be bringing hydrogen to airport, so we'll have a mobile refueling truck that'll be using hydrogen instead of jet fuel. We need to develop new safety protocols for that, because until we have the protocols, we don't know what we need to actually comply with. So it's some of those kind of middle layer enablers that are also really important to develop as soon as possible. Yeah.
Is there any steps that governments should be taking at this point to help the transition? Do you feel like enough is being done, or is it moving the right or wrong direction from your perspective?
Moving in the right direction, but I think more ambitious targets and further support. So we've benefited a lot from R&D funding, which is great, and that's definitely one lever. But there's, as we go through kind of our, valley of death and scale up, there are various points at which alternative capital can be very helpful. And also, of course, policy, carbon pricing, anything that changes that trade-off and that economic decision for companies in favor of green is helpful. We've made our case without that, but it will be that much stronger with it.
Thank you very much for joining me today. It was exciting to learn about ZeroAvia. Check it out, and thanks for being here. Thank you. All right, I hope everybody got some nuggets to take away from this session. We'll be continuing with the next session very shortly. Thanks very much, everybody, for joining, and let's build the future of sustainable transport. Thanks, everyone.